All right, so without getting too complicated here, I'll just tell you the distance formula, which is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so that's our formula for distance. And if we were to just take a peek up here, right, you might notice that the form of it looks fairly similar, right? Except for these two guys looking a little bit complicated. But what these guys are just telling us is if you subtract the x's, you're going to figure out how far it is for A. And then if you subtract the y, it's going to tell you how far it is for B. Okay, so let's trace that back to the first page here. So the distance formula. And you know what? Let's just add these. So midpoint is what is the middle point? And then for distance formula, we're asking how far is it? How far is it? And so we have this, d equals square root x2 minus x1 squared plus y2 minus y1 squared. And just keep in mind, this is similar to the Pythagorean theorem. So if you're ever wondering, oh, what was that distance formula again? Remember, a squared plus b squared equals c squared. A squared plus b squared equals c squared. So why is it nice to know the distance formula? Actually, there's just one thing for this. It's nice to know the distance formula because it tells us how far 2 points are. So if you have any 2 points on a graph and you want to know how far apart they are, you can use the distance formula to find them. Okay? All right, let's just do a couple of examples and then that'll be the end. So page 20 in your books, number 30, it gives you 2 points. So it tells you that r is -4 comma -6. Then it tells you that m is 3 comma -4. And so the instructions say use the given endpoint r and midpoint m of rs to find the coordinates of the other endpoint s. So what this is telling you is that, for example, if you have a point r and then if you have a point s, that there's a middle point here called m, and they want you to use what's given to us here to find the third coordinate. And so in this case, we're trying to figure out what is s. So just by looking at it, would you say that's a midpoint problem or a distance problem? Okay. Hopefully you can see that will be a midpoint problem, because right here we see a midpoint of 3 comma -4, and then we see an endpoint of -4 comma -6. Now we just need to figure out what this guy is. And remember earlier we used the first term as x1, y1, and then the other term as x2, y2. So let's just keep this guy as x2, y2. And let's use our midpoint formula to solve this problem. So to find the midpoint, we know that x1 plus x2 over 2, comma y1 plus y2 over 2 has to equal the middle point, which in this case is 3 comma -4. And then from there, we can put in all of our points. So -4 plus x2 over 2, and then -6 plus y2 over 2, and this has to equal 3 comma -4. And this can be broken up into 2 parts. So -4 plus x2 over 2 has to equal 3. And then -6 plus y2 over 2 has to equal -4. Right? So the way that I did that was I looked at my first term, I matched it up with the first term. I looked at my second term, and then I matched it up with my second term. right? Because they're in parentheses, and the first term has to be the x, the second term has to be the y. And then from here, I do some algebra. So to solve this guy, what can I do? I can multiply by 2, right? So I can multiply by 2 over 1. Multiply by 2 over 1. So once again, negative 4 plus x2 equals 6. Then add 4, So x2 equals 10. And then same thing, multiply by 2, multiply by 2. So negative 6 plus y2 equals negative 8. Add 6, and so y2 equals negative 2. Okay, so my x2 and y2 are 10 and negative 2. So my answer to this problem is 10, comma, negative 2. Okay? And let's go ahead and try number 44. So number 44 asks us, and we'll just do each part. Oh, we'll just do one part. Okay, it says find each segment length, right? So this problem says find each segment length. So is that a midpoint or a distance? It is a distance. Because how far is it? How long is it, right? And in 44, it tells us that E is 1, 4, and F is 5, 1. And we want to figure out how far apart they are. What is the distance, right? So knowing that the first term is x1, y1, and knowing that the second term is x2, y2, we can use our distance formula here. Remembering our Pythagorean theorem, right? A squared plus b squared equals c squared. So this is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And then I just plug and chug. So for my x2 minus x1, right, so for this guy, I can use this guy and this guy. And then for my y2 minus y1, I can use this guy and this guy. And that just, so here's my y2s. There are my x2s. Okay, and I just realized I made a typo, so let me just fix that for us. So this should actually be y1. All right, so let's go ahead and plug and chug. So my distance formula equals the square root of 5 minus 1 squared plus 1 minus 4 squared, square root 4 squared plus negative 3 squared, square root 16 plus 9, square root of 25, that's equal to 5. And that makes sense because we just want to know how far is it. And so from this point to the other, it's going to be 5 units away. All right? Okay, so hopefully that's helpful. So the big ideas from this lesson is to be able to use our midpoint formula and our distance formula at the right times. So when we're trying to find the middle point, we can use the midpoint formula. And then when we're trying to find how far or how long is it, we can use the distance.